make sure to like and subscribe right now. Yes, do it. On it from MathX, and today we're going to be solving the number 24 from the 27 AMC using a little concept called PI, which stands for Principle of Exclusion Inclusion. Now, if you don't know what PI is, it's okay, but try to learn it, as not only does it have a really cool name as PI, but it's also very helpful in math competitions. But anyways, enough talking. Let's just jump into doing some math. So, what is this principle of inclusion exclusion? Well, this concept is a very heavy counting concept. And to summarize a picture and a representation of what we can do in this, let's have a diagram out here. See this Venn diagram. Principle of exclusion inclusion, for example, is if you have the B and C part, you're going to be excluding this entire B circle, this entire C circle, and this red part. So that's like one way to see. But if you don't know what these symbols here mean, well, this U means inclusion, which isn't currently on the diagram, and this symbol means exclusion. For example, in this one, when you're combining B and C, they want to exclude all this B part and all the C part to only have the middle segment. Now, this principle of inclusion and exclusion, PI, is like a counting technique that makes sure when you compute the amount that nothing is counted twice. For example, if you're going to have an overlap between all of these three circles, you would think to have B inclusion C and inclusion A, but there's still going to be a bunch of stuff that's going to be counted twice, and since they need to overlap, you'll have to subtract that. But anyways, since you guys should have understood this concept, we're going to be jumping into today's problem. So this problem, 24 AMC 2017, this is going to be preparing people and showing them a bit of the AMCA test. As, again, good luck on the AMCA test on Tuesday. But anyways, so let's look at this problem. So one thing that I can notice about this is that we have an old person in it, and this old person has 3 grandchildren. So Miss Sanders has 3 grandchildren who call her regularly. One calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. All 3 called her on December 31st, 2016. On how many days during the next year did she not receive a phone call from any of her grandchildren? Now, if you're paying attention for the principle of exclusion inclusion, then you should notice something. You should get the funny brain, a tingle thing in your mind. One thing you can find out is that this involves principle of exclusion inclusion. Now, since we need to find out how many days she did not receive a phone call, we have to subtract a few things using this principle of exclusion inclusion. Because we know that there are going to be 365 days in a year, and we'll have to subtract the days that she gets at least one phone call from the others. And what we're going to have is subtract this. And you may not understand what the 3 and 4 and 5 mean. It's because it says that one calls her every 3 days, one calls her every 4 days, and one calls her every 5 days. And if you're getting confused by the symbol here, this is a floor. So basically, when you have a fraction, you want to simplify it to the lowest integer below it, because you can't have like 3.5s of a call for an example. So we're going to have this kind of form here. Now, the next thing we notice is that we have double subtracted this, because we're going to be subtracting this amount from the total 365 days. So we'll have to add back some stuff because we have double subtracted. So we need to add back the days she gets at least 2 phone calls. And the way we can determine that is multiplying the 3, the 4, and the 5 in different combinations. For example, 3 times 4 is going to be 12, 4 times 5 is 20, 3 times 5 is 15. So we'll have to add the days when she gets 2 calls because we double subtracted. And we'll have to add this back. Now, next, we need to subtract one more thing. And that is the day she gets 3 phone calls. Now, similarly to how we found out the day she got 2 phone calls, we can find out the days she gets 3 phone calls by multiplying all the 3, 4, and 5. And we'll notice that's going to be equal to 60. And hopefully you notice that, because you should. Simple multiplication. But anyways, we'll have to do that. And we'll have to have 365 over 60. And the floor of that is just simplified integer. So next thing we're gonna have is simplify this all into a math equation. Right here, this glorious thing where we can get our answer from. Because after we got all the little segments in it, we can get the final answer, which is gonna make you feel happy. And because it surely makes me feel happy, seeing how Miss Sanders now knows how many days she's gonna get disappointed by her grandchildren. Other than being focused on Miss Sanders' grandchildren, we notice this equation, and now we're gonna solve it. For example, we can simplify this 365 over 3, 365 over 4, and 365 over 5 by using the floor function, and we can simplify these integers. For example, we can add this all 365 over 3 and the others together, and we'll be getting 285 when we simplify it down. And this one here, when you simplify it down, do it in your notebook before I tell you. So just have a second. Now that you're back, we can simplify this part down into 72, and then this one, 365 over 60. 360 over 60 is going to be 6. So then it's just going to take the floor. So we can just subtract 6, and we have it into this equation. Now, this is very simple from now on, because after we just honestly do this equation, we solve it, we're going to get our answer. And our answer is D, 146, after you do the adding and subtracting. So we have D circled here. But anyways, as you can see, we have solved this problem, and we've noticed that Miss Sanders has grandchildren who do not care very much for her. But anyways, besides that, we finished this video, meaning we are now officially finished.